Welcome back to RAG Anatomy, Part 2. Part 1 was the index, ingest, followed by chunk, followed by embed, store. Part 2 is query time, where latency, retrieval misses, and confident wrong answers usually live. We'll cover query shaping and embedding, retrieve, top K, filters, hybrid, routing, optional re-rank, augment, and generate with grounding. Same pipeline skeleton, online path. If something breaks in prod, this half is often where you'll feel it first. Let's start with query. The query step decides what representation of the question you send to retrieval. Retrieval quality is asymmetric. Indexing can be perfect, while one vague user utterance retrieves nothing useful. One technique is query rewrite. You take the user's messy question and turn it into a cleaner search query. Remove filler words, use terms that match your docs, fix it/that from earlier in the chat, and spell out acronyms. Example: user, still not working. Rewrite, app won't open after update. Another technique is query expansion. It deliberately adds synonyms, entity variants, alternate phrasing, and domain keywords. Anything that boosts recall. Before similarity, search fills your top K slots. Example: user asks, login error. Expanded search might include login error, sign-in failure, authentication problem, access denied, SSO login. When one vector still isn't enough, multi-query fans the single user question into several rewritten queries, embeds each, runs retrieval per branch, merges, and dedupes results. Recall wins. Budgeting latency and noise loses unless you prune carefully. Example: user asks, why can't I log in? System runs 3 searches in parallel: login failure troubleshooting, password reset not working, SSO authentication error. One question becomes several searches, then you combine the results. Better recall, but more latency if you're not careful. Multi-hop tackles questions that imply composed evidence. First hop finds candidate entities or anchors, intermediate answers become queries for subsequent hops. You orchestrate hops with explicit retrieval windows, freshness rules, stopping criteria, otherwise cost explodes chasing shadows. Example: user asks, which refund policy applies to order number 48291? Hop 1. Search order 48291. Find it's an enterprise plan, bought last month. Hop 2. Search enterprise refund policy 30-day window. Pull the right policy doc. Hop 3. Optional. Search refund steps. Enterprise billing portal. Get the how-to. Each hop uses what the previous hop found, not one shot from the original question alone. Eventually, you freeze rewrite decisions into embedding inputs. Embed with the same embedding model, tokenizer limits, normalization conventions, and distance metric semantics promised at index time. Cross-space math is brittle. Versioning your embedder beats debugging impossible recall regressions silently. Operational guardrails worth naming: telemetry on truncation, hallucinated query additions in expansion, tenancy filters applied, same hop embeddings land in, deterministic seeds for merges, so eval's reproducible. If this helped, like and subscribe. It pushes the lessons to people who actually care about the topic, and you'll catch the next videos in this series. It costs you nothing, but it means a lot to me and my team. If something clicked or you have a question, leave a comment with your use case. I read comments, and they steer what I publish next. To learn more about me, visit this page. For agents, RAG, MCP, and related pages, visit this page. Same links are below in the description and pinned comment. Huge thanks. Your attention makes the work worth it for me and everyone behind the channel. Retrieve is where the index pays off. You take the query vector, and sometimes parallel sparse signals, and ask the store for the most relevant chunk IDs under your constraints. The default move is similarity search over dense vectors, usually top K neighbors. K trades recall against noise and downstream cost. Bigger K feeds re-rankers, but also drags irrelevant text into the prompt. Real systems rarely search the whole universe. Metadata filters scope by tenant, product, language, document version, date range, channel, whatever your payload indexed. Bad filters look like model forgot. They're often empty recall or stale corpora, not weak embeddings. When dense alone misses exact tokens, SK-US, error codes, legal phrases, teams add hybrid retrieval, BM25 or another sparse score fused with vector similarity, weighted sum, RRF, learned combiners. You're buying lexical insurance next to semantic paraphrase. At scale, you add partitioning and routing, shard by customer, geography, product line, or topic, so each query hits a smaller, cleaner sub-index, faster, cheaper, less crosstalk. More advanced stacks route queries to different corpora or tools based on classifiers or rules. Output of this stage is a candidate set. IDs, scores, payloads, not the final answer. Precision gets refined in re-rank. Truth gets assembled in Augment. So treat retrieve as broadnet plus hard constraints, not literary perfection. Vector search is fast because it compares pre-computed chunk vectors to one query vector, millions of candidates in milliseconds. That speed comes with a trade. Each side is embedded in isolation, so fine-grained relevance. This paragraph actually answers the question. Can be noisy. Re-ranking is the precision pass. You take the shortlist from retrieval, maybe dozens to a few hundred candidates, and score query document pairs jointly. A cross-encoder feeds question plus candidate chunk together through a transformer, outputs a relevance score. That joint attention is much sharper than cosine between two independent vectors, but linearly expensive in shortlist size, so you never run it on the whole index. People call this step optional because small corpora, tight metadata filters, or strong hybrid retrieval sometimes make raw top K good enough. In help desks, legal, compliance, or code Q&A, skipping re-rank often shows up as right neighborhood, wrong paragraph. Engineering notes, cap max candidates, batch score for throughput, cache stable pairs if queries repeat, fallback gracefully on timeout, log score distributions to catch drift when you swap models. Delivers to Augment. An ordered, pruned set the model can actually read without drowning. Augment is where retrieval becomes instructions the model must obey. You assemble a prompt from controlled pieces, not vibes. System policy defines role, tone, refusal rules, citation format, sometimes skills or tool protocols if your stack packages behavior that way, then grounding blocks, the re-ranked passages with stable labels or source IDs so the model can point back to evidence. Add conversation or session memory only when it's scoped. Summaries of prior turns, user preferences, not an unbounded dump that drowns the chunks. Finish with the user question, explicit about what constitutes a sufficient answer. Order and token budget often determine success. If the question is buried under 80 kilobytes of PDF content, the model may focus on the wrong constraint and produce an inaccurate summary. A typical prompt structure begins with a concise system header that defines the model's role and rules. This is followed by labeled evidence containing the retrieved passages and source references. Next, the prompt includes a reminder to remain grounded in the provided evidence unless explicit inference is allowed. Relevant conversation memory is then added in a trimmed and focused form containing only information that supports the current task. Finally, the prompt concludes with a clearly defined user question and explicit instructions describing what constitutes a sufficient answer. Structured outputs, JSON schemas, enums, and citation arrays force answers into predictable formats that downstream systems can reliably consume. Keep schemas strict enough that hallucinated fields fail validation and tests rather than silently corrupting dashboards or application state. Operational mindset, reproducible prompts, deterministic chunk ordering, versioning of templates, refusal when evidence empty. Augment determines truth surface area. Generation never exceeds. Generate is the language model's turn. It reads the augmented prompt, system rules, retrieved passages, question, and writes the user-facing answer. The whole RAG design assumes grounding. The model should treat retrieved text as primary evidence, not as loose inspiration. That means your system instructions say what grounded means in your product. Quote or paraphrase with citations, flag uncertainty, refuse when chunks don't cover the ask, never invent policy numbers or URLs that aren't in context unless you explicitly allow external knowledge. Critical honesty. Retrieval plus instructions reduce confident hallucination. They don't delete it. Models still overreach, merge incompatible snippets, or misread tables. That's why production wraps generation with eval hooks, citation checks, entailment against sources, human review queues, or automated regression sets. Engineering levers. Temperature low for factual help. Max tokens tuned so answers stop instead of rambling. Structured output if downstream needs JSON. Streaming doesn't change grounding. It changes perceived latency. Output isn't just text. It's traceability. Which chunk IDs supported, which claims, what was filtered when the model abstained. That audit trail is what turns RAG from demo into operable software. That's the anatomy end-to-end, ingest. So text is trustworthy, chunk, so retrieval units carry meaning, embed and store, so search is fast and auditable, query and retrieve, so recall matches how users actually ask, re-rank when precision still leaks, augment, so the model sees a governed evidence pack, then generate with explicit grounding rules and traceability. Nothing here is magic. Each step hands constraints to the next. When RAG feels dumb, the failure is usually 2 hops upstream of where people look. Bad splits, wrong filters, query index skew, or prompts that let the model freestyle past the passages. Ship the minimal pipeline that hits your quality bar. Instrument every hop latency and empty retrieval alarms. Iterate with evals, not vibes. Done right, RAG is boring infrastructure. Retrieval proposes facts. Generation explains them. I appreciate you making it to the end. These aren't quick overview videos. If you got value here, liking and subscribing is the low-friction way to support the work and stay on the series. No pressure, but it matters. Questions or a real workload? Comment below. I read them. Thanks again. See you in the next one. Thanks.